Actually, I wanted to do astronomy when I was a kid. And I woke up at 2 o'clock in the morning to watch stars and stuff. But gradually I got more and more interested in what all this stuff is made of. I become increasingly interested in what is an atom, and then I realized there are protons in an atom, and I wanted to know more about what's inside protons. And little by little, I got very interested in what nuclear matter under extreme conditions looks like. What is it that is inside stars? But what's inside exploding stars? Or what is in collisions between neutron stars? And actually, while I'm at it, what actually looks matter-like when we're just a few microseconds after the Big Bang? I try to do these collisions in a very safe environment. So a safe environment means I have a lab that is at a collider facility. In my case, the experiment that I'm working on mostly is at Brookhaven National Lab. There's the Relativistic Heavy Ion Collider, which is a mouthful, but we call it RHIC, this is easier. So at RHIC is where my work takes place, my daily work. And what I do at RHIC is a combination of things. I, on the one hand, work on designing detectors and developing detectors that we're going to use to detect these particles. And on the other hand, we're looking at actually the data that comes out of these collisions. I started in STAR as a young postdoc. Basically, in the first year, it started taking data. And as many in STAR, I've kind of grown into this experiment. I've played several roles in this experiment. Recently, I was elected to be the STAR spokesperson. I feel very honored to help guide this experiment through what will be the last years of data taking. It's going to be the end of an era of STAR, not followed by the end of STAR. Rather, it will be followed by people looking at the data that we collected in those 25 years, doing experiments all over again, but now on the data that we've been able to collect over all the time.